Good afternoon, Build Stuff, and welcome back. Hope you're all having a fantastic day out there, enjoying all of the great sessions, technical content, some of the best speakers from around the world, streaming content directly into your house. Kind of a fun year if your idea of a good time is going to a conference, but you can keep your shoes off and hang out with your cats and your dogs and all that kind of stuff. It is my pleasure to introduce to the stage. Next up, we have a double act. We have two speakers in the next one. They're going to be sharing their stories about adventures in multi-cloud with Kubernetes. Please give a big warm welcome to the Build Stuff stage, Augustinas Stirbis and Laurent.
Thank you very much, guys. I'm sharing my screen so everybody can see it. Excellent. So, guys, it's a pleasure to speak to you. In fact, it's one of the first time we speak in a conference as CAST. We started the company about a year ago, so it's a double pleasure because we are going to show you some of the stuff we've been working on, and also some of the belief we have and the reason why we did this. We want to talk to you about an adventure in multi-cloud with Kubernetes. We're going to show you what we mean with multi-cloud and why we're so excited with this. And then Augustinas, who is my other co-founder who ran our development team, is going to go over all the tricks, the issues we found, and he will install actually a real application live in a few public cloud providers. And again, my name is Laurent. I'm one of the founder of the company. So it's a pleasure to be here. First, as I said, it's a demo or it didn't happen. So we're going to make sure we show that to you. And so it's not yet another boring presentation. Hopefully you guys will agree. But yeah, we want to show you the real stuff instead of showing you some slides. Before we start, I just frame a few concepts, containers and Kubernetes, just so with a bit of history. As we all know, 20 years ago, the ideas of data centers was, hey, let's put a lot of bare metal servers in one place so we can share electricity, air conditioning, and physical security. Sound like a very great idea. A lot of people liked it as well. But then very quickly, some of the guys, especially our friends at Amazon, start to feel, well, you know what, this is great, but bare metals are not very often used. So let's see if we can make some dense compute on these machines, and that was the introduction of the VM, and that's what made AWS what is AWS today. At some point about a few years ago, people start to feel, yeah, this is great, but you have a lot of overhead with the VM, especially the fact that you have to replicate the operating system many times, and that's not very efficient. And that was the birth of the container, and this is where we are, and this is why we are so excited to be in this business. The containers is the fantastic place to use your machines in a very dense mode with a very light overhead. You see, especially the operating system has disappeared, and now you can really share the machine with many different workloads to the most of your ability. So that's why we're so excited. That's why we're all in this business. The birth of the container, I think, has changed the way we see cloud and made it a lot more popular. The second thing we want to say is Kubernetes is a clear winner in how to manage containers. I think there is no more doubt about this. This is actually a graph of utilization of Kubernetes. You see everybody else has disappeared. And our great friends at Google did a really great job to develop and open source Kubernetes for all of us. So that our multi-cloud adventure is going to be based on Kubernetes only and using the idea of the containers. What is multi-cloud again? There are many definitions. This is our. So this is where you are, and you are sitting in front of these big walled containers or containers, physical ones, with big walls. One is Google, the other one is Azure, and maybe the third one is AWS. This is how we feel multi-cloud should be. We feel that the developer should have access to all the resources of the 3 cloud providers or 4 cloud providers or any cloud providers without walls. So complete freedom to install things in any place, anytime. Why should it matter that you select one over the other if you have a way to deploy something in all of these clouds at once? The way we think of cloud is we want the data to be shared regardless of where the workloads are. So it's a data multi-cloud. It's a service multi-cloud. We want all the services, cloud native service of one cloud to be available on the other. So think here as if you're using RDS database of Amazon, and you also have a process using the ML engine of Google, why not having these two things work together so you can use the best of Google machine learning services at the same time as some interesting database concept of AWS. And then finally, the workload should also be multi-cloud. And this is how we feel multi-cloud should be, where application and data work together through processes that may happen to be installed in machines. Some of them are owned by AWS, others by Azure, and others by Google. It should all work at the same one application that stretch around these places. So the way we mean about multi-cloud is exactly this one, the ability to create and manage a Kubernetes cluster in any number of cloud. In fact, so much so that cloud becomes, or the multiple cloud, or the amount of cloud you use becomes irrelevant. What you have as a developer is an application. You want to deploy this application on a cluster, and then you want this cluster to be optimized all the time. That's what we think multi-cloud should be, the true story of multi-cloud. Why it's an adventure? There are two reasons for it. Because the vendor lock-in is evil. And I'm going to show you an example of this. We did a comparison of how much compute per dollar you can buy on different cloud providers, and the result is staggering. So here I'm going to compare Amazon, Google, Azure, and Oracle in US Central. I'm going to compare these for 4 core machines just to see how they look different, even though they're all 4 core machine, and many times they share the same processor. So I'm showing the result, and this is what you get. This is why we think vendor lock-in is evil. So you see, the first 2 results. Google Cloud is actually the best price, and these are list price, so this public price you can get from them, $72 a month. But look at this, for about 10 or 12% more on Oracle, you get the same 4 core machine, but look at this. You get actually twice the amount of compute. This is normalized compute. So we benchmarked it. So we calculated how much compute you get for that machine, and we made it comparable between one to the other. So effectively, for 10% more, Oracle 4 core machine in US East give you almost a little bit more than twice the compute amount. And then a lot more time, 6 times more memory, of even more than this. So you see, the point is, vendor lock-in is evil because Google Cloud makes sure you can't move a workload to Oracle. You cannot benefit from difference of prices. And look at this, even if you're on Oracle only, look at the first result and the third one. The third one has, 10% more power, but the price is double compared to the first. So that really means selecting your machines is important, and vendor lock-in is evil in this case. As a developer, I'd like to use the cheaper option, but I can't if I'm locked in inside Google. The second thing that made it possible is what we call the Goldilocks zone of 5 milliseconds. And here we also did a little bit of data scientist work where we started to compare, or to calculate how far these cloud providers are from each other. And the result was staggering. If you go to, let's say, very hard place to work, hard place mean very expensive place to work, to use cloud, this is Asia Pacific, Mumbai, AWS. What was very interesting to us is the realization that, well, if you use AWS in Mumbai, you are in fact less than 5 milliseconds away from Azure, Google, and Oracle. 5 milliseconds for us is the Goldilocks location, which means that if an application span across these 4 cloud providers, the application will work out of the box because the network is so strong that you have only a 5 millisecond latency between them. And you can look around and play with, let's look at EU Central, so Frankfurt, which is typical for Europe, where you would want to be. So here we're comparing AWS in Frankfurt with Oracle is 1.7 millisecond away. Google is 1.8 millisecond away, and Azure is 2.1 millisecond away. And then you can play around and say, well, if I'd like to use Switzerland, it's 6 millisecond away. But look at the difference between them. There is a big pack of cloud providers that are within 5, 3, 2 millisecond away from each other, which means that, yes, if you can span an application across all these places, the network is such that this thing is going to work by itself. That's why we're so excited by this. Better is to show you things in real life. So, and Augustinas will show you how we deploy this, but we did deploy an application in these 3 clouds. This is actually application made by Google. It's completely open source. It's an e-commerce app. And this is a Kubernetes application. we absolutely did nothing to this. We took it as it is and we installed it on a cluster that happened to span Azure, AWS, and Google, and we have made zero change in this application. So let's say as a customer, I go here and I like this typewriter. I'm going to say, great, I'm going to add this to the cart. Look, we are showing what is the entry point of this application. Right now, it lives inside AWS. So I add this to the cart, and right now, I'm actually Azure is actually streaming this page with my shopping cart have one element to it. I go back to the homepage. Now I'm on AWS. I click on the camera. I say, oh, this is great. I'm gonna buy. Oh, dude, I really like this. I'm gonna buy 3 of them. Add to cart. So now my cart has 4 items, and it's being streamed by AWS. If I refresh this, it's not going to be streamed by Google. If I refresh this again, it's going to go to AWS, to Azure, etc., etc. You see, what we really like with this is the ability for any Kubernetes app, without any change to the application, to be installed on a cluster that spans 3 clouds with full data persistence, which means that my shopping cart is the same. It doesn't matter where this is being streamed. This application just works out of the box in a multi-cloud environment. And what that means is there is no vendor lock-in. If I want, I can use the most efficient machines that are available on these 3 clouds in Frankfurt, because I just saw how different prices may be between these places. So now I'm going to give the screen to Augustinas, who is our head of development, and Augustinas will tell you how we did this. Augustinas, it's all yours.
Hello, can you hear me?
Yes, we can.
Okay, awesome. So thank you, Laurent. My name is Augustinas, and imagine one day you check your work email and there's a message from your company leadership saying, great news, we as a company going to multi-cloud, make it happen. So probably quite a few engineers will have different emotions here. First one, what is this email? Was my management was smoking something again? I want that stuff. Then you could have a denial stage where would you say, dear manager, there's no such a thing as a multi-cloud. It's a conspiracy by small clouds just to stay relevant. You might have anger, like, why my management do this to me? I have so much work. Why this multi-cloud now? Maybe next year. So you can start bargaining, saying, well, we're using these SaaS services already, like GitHub, Jira, Slack. Aren't we multi-cloud already? Then some of you can have even depression, like my manager doesn't even understand the complexity of multi-cloud. That probably means that I'll have to use lowest denominator feature of all the clouds, all the data gravity problems. I have to learn a few clouds. Then even if I learn those clouds, these clouds name similar things by different names. They use different syntax, different arguments for same things. It's hard. And keeping costs on all cloud providers, it's a nightmare. But finally, as all stages of grief, you finally go to acceptance. Oh, well, as I saw in conference, Laurent demonstrating it's possible to run application on multi-cloud. So let's give it a shot. So let's build multi-cloud solution. So first, we need to pick technology, how applications are being developed and packaged. So container is, according to Gartner, default choice if you are to start writing new applications. But functions are still growing every day. And if you're going public cloud, it would be waste not to use cloud native services. I personally think that Kubernetes ticks all the boxes. It is de facto standard for container orchestration. There are a bunch of frameworks to run functions on Kubernetes. And if you have Kubernetes on public cloud, application inside Kubernetes usually can use any cloud native services without any limitations. So here you come to the first bigger architectural decision that you have to make. So one is multi-regional. That means, for instance, that you have customers all around the globe and you want to place your application in very distant data centers from each other with the huge latencies between them. And that probably means having very complex application written for that. You probably will not avoid sharding your data, introducing eventual consistency, having all the data concurrency problems. And it is very hard not to crack. Usually it's not possible to achieve good performance and consistency if you don't write your application from scratch specifically for multi-regional setup. I guess it's way easier problem if you can keep your infrastructure in one location, for instance, Europe, and if latency to your customers is not that important, or your customers are in a region like Europe or US, I would prefer to go with the regional. So if you decided that your infrastructure will be in a region, you have three choices here. So one is you can build independent Kubernetes clusters on separate cloud providers, and those clusters will know nothing about each other. So you will have DevOps processes and procedures to set up pipelines to push your applications and configuration to separate Kubernetes clusters and making sure there's no drift. So for instance, today Google Anthos works in similar way, but that kind of introduces the problem. It's kind of all nice for stateless application, but how do you do data synchronization? Where do you keep the data? So these are the hard questions. Second option is cluster federation. So similar, like a first choice, you have independent clusters, but these clusters are glued together with the service mesh technologies. So most popular ones being Istio or HashiCorp Console. So these service meshes allow clusters to communicate with each other by introducing custom resource definitions. So, but that then complexity falls on application owners to write application manifest to consume those custom resource definition. That's the additional complexity to application team. Also, these service meshes usually implemented through reverse proxy like Envoy, and it adds significant latency, network latency, let's say about 20 milliseconds. So even if you see, Laurent saw, there are regions which have only 3-5 milliseconds, and here you add 20 milliseconds between boxes that are sit close together. And the last option is stretch cluster. It's where you just deploy single logical cluster on many cloud providers in these multiple cloud hotspots, and it's just one cluster, no federation, no synchronization. Everything is a single unit. So it could not have been done just a few years back. Over a few years, cloud providers built many data centers around the world. And if you see on the map, these are hotspots that Laurent demonstrated. And yeah, it makes it very easy to build Kubernetes. And it means that you should be treating different cloud as a separate, as an availability zone. And you can build Kubernetes on different availability zones, so there's nothing different here really. So stretch cluster have few unique opportunities here. So one being, if you're deployed your Kubernetes on 3 clouds, you can use native services from all 3 clouds. So if you want to use Azure Active Directory, DynamoDB on AWS, and Google AutoML from same application running same Kubernetes, you can, because it's in one network and accessible to all clouds. So another point is capacity. So for instance, when the first wave of COVID pandemic hit, Zoom had very rapid growth, and their provider at the time could not keep up with the demand. So Zoom, during all this panic of pandemic, they had to migrate all their workloads to Oracle Cloud just to get additional capacity, because some cloud providers were completely out of capacity. And last point is spot instances. So spot instances is clouds resell their spare capacity with 90% of discount, with caveat that any minute they can ask you to return it back with just a minute or 2 notice. So major 3 cloud providers have spot instances, and when you're sitting on multiple cloud providers, you are in the 3 markets. So likelihood that cloud providers will ask you to return preempt all your virtual machines is way smaller than you are on a one cloud, meaning you can build much more resilient application on much more affordable compute. Alrighty, so we're gonna go a bit more technical on how to set up Kubernetes and cloud. So I'm just gonna quickly remind main Kubernetes terms. So one is master. So master usually is a server that is brains of Kubernetes. You put only control plane components on masters, and some cloud providers even hide masters completely for you so you don't screw up with your Kubernetes. Second is node. Node is a server which hosts your applications, and node can be a virtual machine, it can be physical server, whatever. And lastly, pod. Pod is a single instance of application. Usually it's a one container, but it can have additional helper containers, and yeah, so application can have many pods. All right, so as exercise, so you've been tasked to build multi-cloud. We're gonna build it in a region, single region, Frankfurt. So Frankfurt is like 26, 27 milliseconds away from Vilnius, from where I am now, and let's build multi-cloud Kubernetes. So in Frankfurt, if you check, there are like AWS, Google, Azure, DigitalOcean, Alibaba, IBM, Oracle, Hetzner, Linode. Those are 9 that I know, and there are probably many more that I am not aware. So you have quite a bit of freedom to decide which cloud providers to use, and they are all in this Goldilocks latency zone. So to build Kubernetes, you have to have cloud accounts on major 3 cloud providers. All of them give you free accounts, like with $300 to play around, so you don't have to really spend any money to test what we're going to show you today. So you have accounts on 3 clouds. You can create VMs. Now, just before starting installing Kubernetes, you need to make sure that your VMs can talk to each other. And of course, obvious choice is VPN. Major cloud providers have pretty decent VPN, which is decently priced. They have SLA, it's a 1 gig speed, and it's pretty okay, I would say. One caveat, Azure doesn't play well with other cloud providers on BGP connections, so you'll have to manually fix that because Azure doesn't play with standards well. Other alternative is you can opt not to use a default cloud vendor VPN, which is based on IPsec, but rather you already have VMs on each cloud, and these VMs usually run Linux. And as you know, Linux already have WireGuard VPN capability in a kernel already. So you can establish your VPN infrastructure between all these 3 clouds nodes. And I posted a GitHub link here to Project Kilo. It's a Kubernetes and WireGuard project, which allows you to really quickly spin up this network mesh of VPNs between different cloud providers or different data centers. So if you want to host data-intensive applications and internet might look not reliable to you and you need reserved bandwidth capacity between cloud providers, there's possibility to connect physical fiber cables between major cloud providers. And companies like Equinix or Megaport can help you to do that in just a few minutes or with a few clicks or APIs. And added benefit is that if you go with the direct connect and these fiber connections, the egress cost gets reduced by 4 times. So it's much more affordable to send data between cloud providers. So last choice before we can go to installing Kubernetes is you have to pick Kubernetes network plugin. Most popular Kubernetes CNI network plugin is Calico. Unfortunately, it doesn't work on Azure Cloud. If you're not going to use Azure, you can free to use it. But if you will use Azure, you have to use some CNI plugin which leverages network layer 2. So VXLAN, Geneve, or other overlay protocols needed to help all the network complexity from cloud providers, and that the cloud providers will not drop your packets or inspect them. So you have connectivity between your virtual machines, and you decided what technology you're using inside Kubernetes network. You're free to just go download kubeadm tool with a single line of command, install Kubernetes, and you're good to go. And actually, you don't need nothing else if you want to just run stateless applications. But I mean, who needs just stateless applications? We all usually need some state to store, and stateful application usually requires some persistent storage. Kubernetes here has support for major cloud providers, which is called entry drivers, or possibility to install any cloud storage driver. So these drivers do dynamic provisioning, they attach volume to the node, they format drive and allow application to use without any manual process from you. It's very useful. So if you use out of tree drivers, these are recommended, as entry drivers are being phased out slowly, and out of tree drivers has capabilities like they can expand volumes on the fly, even without the need to reboot application. With the small caveat, Azure doesn't support that feature. They said that it's coming at some point. So now we with Kubernetes, we can install driver and we can provision volumes on any cloud. Now is the question, okay, if I have my application, I'll have to specify from which cloud that application should be using disk volume. And you kind of start doing Kubernetes scheduler work because you're deciding where that application should be placed. So there's an alternative. You should let Kubernetes scheduler do its job. And we at CAST has written a CSI driver that will create volume on any cloud your application will be put by Kubernetes scheduler. So watch out for announcement of us open sourcing this driver. Another storage question you have is portability. So you're on multiple clouds, how do you keep the data? So best data replication options are, of course, at the middleware level. So most databases support synchronous or asynchronous replication. So one really promising company is Yugabyte. They were especially built for multi-cloud, and they support like Postgres, Cassandra, and Redis APIs on the same database. So it's really good fit for multi-cloud. If you don't have any middleware that does the replication and you need to move your data once and for all from some particular cloud and never go back, so you can extract your content from disks with the volume snapshots. Google and Azure provide these snapshots, and you can export them to object storage and import on other cloud as the Kubernetes volumes, and it will work fine. AWS here is a bit douchebag, and they do not allow to export disk storage snapshots out of AWS cloud. That means you'll have to use some backup solutions, disk partitioning, disk imaging solutions to pull that out and redeploy. Third alternative, there are some storage abstractions that could live between your raw cloud storage and Kubernetes that will give you flexibility to move data around. So for instance, open source project like OpenEBS, it's a good tool to play around. The problem is that it takes about 10 times the performance penalty to actually use it. So not a great choice. So now you have Kubernetes with working network and ability to provision storage. You have a working cluster, and that leaves compute. Compute usually, so that's usually CPU and RAM as virtual machines. Compute is the biggest spend on any cloud. And Laurent mentioned that we have this cloud compare tool that helps you pick best VM types for your workloads. But when you picked specific VMs, you still have to have some autoscaler that will increase number of VMs and decrease when you don't need it. So we engineers tend to over-provision number of VMs because nobody wants to be woken up in the middle of the night to add additional capacity. So we just add more capacity than is required, and then our companies are pay. So some node autoscaler is needed. Unfortunately, I'm not aware of any open source project that could help you here in a multi-cloud setup. But if you find one or you write one, you would want your autoscaler also to have like guardrails, like minimum and maximum CPU or RAM. You want to provision if in case your cluster goes cluster autoscaler goes crazy, so you don't provision million cores or goes to zero. Secondly, when we have node autoscaling question answered, then how do you scale your applications? And remaining two topics are not related to multi-cloud. These are relevant to any cloud, to any single cloud or on-prem Kubernetes. So Kubernetes has a horizontal pod autoscaler, which helps you increase number of applications to keep with the load. But we saw that KIDA project, Kubernetes event-driven autoscaler, is a great add-on on top of HBA, and you should be using them together to intelligently increase number of replicas and reduce when the need arise. Lastly, deciding how much CPU and RAM you have to give to your application is really a hard problem. So open source projects like Goldilocks help you pick the right size, because if you pick too low resources, your application will be crashing due to out of memory errors, or if you provision too much, you'll be wasting resources. So Goldilocks can help you here. And that's basically it. You have a working cluster. What you still need to do to expose your application to internet. So as we are on multiple cloud providers or different data centers, we need some global load balancer, some SaaS service that could distribute load between multiple cloud providers. So these GSLB providers can come in different shapes. So some do just simple round robin, others could do health checks, metric-based load balancing, utilization balancing, so they can smartly distribute load, and if one cloud fails, they will not send traffic there. So when traffic hits then your data center, you need to have something to ingest that traffic, and believe that exposing virtual machines directly to internet, it might be a bit not careful, and you should be exposing through load balancers. As a caveat, not only these load balancers distribute load between virtual machines, but also they do basic sanitation as DDoS protection and limiting what ports are open to your cluster. Inside Kubernetes cluster, if you want to expose HTTP application, you have to pick ingress controller. There are like 15 of them on Kubernetes side, so popular ones being Nginx, Istio, Traffic, or HA proxy. Any of them will do. And also, if you're lazy like me and you don't want to manage certificates on your own and renew them every year, you can install Cert Manager that can work together with Ingress Controller to automatically create and renew Let's Encrypt certificates. And lastly, you should label your Kubernetes nodes with specific labels so that it gives you freedom and flexibility to optimize how the traffic and your application placement goes, so that you can define an application manifest. Meaning if traffic on this diagram hits Google data center, I would want to minimize number of jumps to different availability zones as much as possible and keep traffic in one silo if it's possible. And topology-aware routing can help you achieve that. Alrighty, so demo time. I have a Kubernetes cluster. I have a Kubernetes cluster. It's 6 nodes. I'm gonna open here. So you can see 6 nodes on 3 clouds, so 3 master nodes, meaning if one of the clouds to go down, our Kubernetes will just shrug it off. Not a big problem. So yeah, as you can see, it's Azure, Google, and AWS. So one master and one node on each cloud. And for instance, if I open Cilium health status and we're using Cilium CNI, you would see the latencies between all the nodes in Frankfurt. So you'd see it's like 3, 4, 7 milliseconds. And so the latencies, this is inside Kubernetes over VPN. And so we're not faking these latencies. So my cluster have created, there's a global bouncer created for my cluster. I'm using one of the SaaS providers that give that possibility. So I have this URL that will do global load balancing, and it will distribute loads between load balancers on 3 clouds. So AWS, Azure, and Google. And so if I want to expose my application, I need to point my business beautiful name to this global load balancer. So I go to GoDaddy DNS, and I already created DNS record build stuff for this global load balancer on my DNS zone. So I hope that demo gods are going to be online with us today. And if I go to this URL, you'll see that nothing is responding. I'm getting Nginx not found. So this is reply from my Ingress controller that there is no application deployed. So I'm going back to my Kubernetes, and I'm using Lens client, but you can use anything. So if I go to pods and choose default name system, there's nothing. You can see my cluster is completely empty. And we have this application shared on our GitHub. Laurent already demonstrated. So I'm just going to quickly deploy it by applying this manifest. So while it is deploying, I'm going to quickly walk you through to show that this application is nothing special. It was not adapted to the multi-cloud, just a regular your day-to-day application. So going from a bottom is like I have Ingress controller, and I'm going to say that I want application to be visible on this DNS and on this path. I want valid TLS certificate from Let's Encrypt. What else? So, for instance, if I go to my Redis card application, this Redis database uses persistent volume storage. And if I go to persistent volume claim here, you'll see there's nothing cloud specific. It just gives me 10 gigabytes of storage, which is read-write once type, and that's it. So there's no need to specify specific cloud where you are. So for instance, but you also can have flexibility if you want. So for instance, the application that Laurent just demonstrated, we wanted to split that. Some workloads will be on 3 clouds. So you can have like default Kubernetes affinity rules to saying that your application should be on the nodes with these values. And for instance, you want to have pod anti-affinity that they distribute on all the clouds and not just clump up. So if I go here, so I'll see that volume claiming has been created, and I can go to applications, refresh it. So application is getting built yet. So, but if I go to, sorry if developer tools are not visible here, but as you can see, it's a valid certificate. It was built by Let's Encrypt, and in few moments, yeah, as you can see, now it's working. So, yeah. So getting back to my slides. So I showed you the demo. So to play around, once to click it with the hand, it's all fine. But ideally, you would want to write infrastructure as a code to have it repeatable, different environments or different regions. So you should be using some infrastructure as a code tool. CloudFormation or Deployment Manager are usually 2 vendor specific. They are not a good fit, but Terraform, all cloud providers has written Terraform providers for them, and you can leverage and use them. So you can build. So what you've seen today, you can build yourself, and you don't have to use any proprietary software. So thank you. Questions?
So a question from Aurelius is, there was a question out of capacity. Did it mean no capacity for a specific configuration, or just unable to create a cluster from multiple size instances? I think Rokas has answered that one in the chat already, if you can take a look, but do you have anything to add on that?
So major cloud providers like AWS, you could not get any capacity. For instance, in April, if you asked, can you add 100 cores to my account? AWS say, take 2 or leave it. So they would not able to give you anything.